Sensory motor feedback mechanisms, a conceptual story. Recall, the body and the brain and the spinal cord are in constant communication. The communication that comes from the body to the central nervous system takes an afferent pathway. The communication from the brain to the body takes an efferent pathway. Okay, let's get to the story. Once upon a time, there was a place called Muscletown. In Muscletown, there was a big apartment complex called Fascicle Flats. It was a busy place, full of interesting characters. In each apartment, there was a guy named Muscle Fiber. He was also called muscle cell or myocyte, depending on the day. In the middle floors of the apartments, Muscle Fiber lived with a pal, a sensory receptor named Muscle Spindle. You could say they lived in the belly of the apartment complex. Spindle was a cuddler. Spindle and Fiber liked to lay around side by side all day, and Spindle would hold on to Fiber's head and feet, which is kind of weird, but hey, we're not judging. Now let's get to know Muscle Fiber a little better. He is made of extrafusal fibers. This means bits of him called actin and myosin contract. We'll talk about those things later. He connects to tendons, which means he's the one causing movement inside the muscle when he contracts. The signals he gets from the central nervous system come from alpha motor neurons. Now, how about Muscle Spindle? What's he all about? Spindle is linked up with special intrafusal fibers, nuclear bag fibers, also called type 1A afferent, and nuclear chain fibers, also called type 2 afferent. He's a super sensitive guy, which is probably why he loves to cuddle. He can tell when muscle fiber stretches, even just a little bit. And the signals he gets from the central nervous system come from gamma motor neurons. Spindle has some important jobs. He's a proprioceptor, which means he's responsible for giving lots of sensory information to the central nervous system. He talks back and forth with the CNS all day and decides how to set the tension of all the muscle fibers. So when a stretch feels too dangerous, Spindle here activates the stretch reflex to keep the muscle fiber from getting hurt. It's because he's such a sweet guy. Now, in the top and bottom floors of Fascicle Flats, Muscle Fiber lives with another cool dude named Golgi tendon organ, but we call him GTO for short. What should we know about GTO? Similar to Muscle Spindle, GTO is a sensory receptor and a proprioceptor. Lots of feels are happening around here. But unlike Spindle, GTO doesn't cuddle up with Fiber in parallel. He's all woven up with collagen fibers instead, and he lies head-to-head or in series with Fiber. GTO communicates with the CNS via type 1B afferent fibers. GTO is not really affected by stretch, but he's sensitive to tension and compression in the muscle. When there's too much tension and compression, he communicates to the CNS and says, "Danger!" And then the CNS sends info down the alpha motor neurons to muscle fiber to inhibit contraction. So, let's recap. In every muscle, there are many fascicles. Inside each fascicle are a bunch of muscle fibers, also called myocytes or muscle cells, and a bunch of sensory receptors called muscle spindles and GTOs. Muscle spindles and GTOs are both sensory receptors and proprioceptors. Muscle spindles run parallel to muscle fibers, and GTOs run in series with muscle fibers. Spindles live in the muscle belly, and GTOs live at the ends in the musculotendinous junction. Muscle spindles are made up of intrafusal fibers called 1A and 2, and they travel to the CNS. GTOs are made up of 1B afferent fibers, which take messages to the CNS. Spindles measure length and speed of contraction in muscle, whereas GTOs measure tension in the muscle. Muscle spindles cause reciprocal inhibition, and GTOs cause autogenic inhibition. So, the stretch reflex, also called the myotatic reflex. So muscle fiber and muscle spindle are hanging out in the muscle belly, parallel to each other, like we said before. When spindle notices something, fiber is stretching. Now, something you should know about spindle is he's a big worrier. So when muscle fiber starts to stretch, spindle's like, that feels like it might be dangerous. So immediately, muscle spindle springs to action to help his friend fiber. He sends a message to the CNS via the nuclear bag and nuclear chain afferent fibers. They have that exact info on the velocity and the length of the stretch that's happening. So the CNS considers the data that spindle just relayed, and he says, you're right, this might be dangerous. So to make sure that muscle fiber doesn't get hurt, CNS sends a message down the alpha motor neuron to fiber, telling him, stop stretching, please contract. So muscle fiber contracts, and all is well in fascicle flats once more. But I know what you're thinking. Does the CNS ever disagree with spindle when he worries about too much stretch? And the answer is yes, he does. Sometimes the CNS considers the length and the velocity of the stretch that's happening, and he says, I'll allow that, spindle. You should take note of that this much stretch is okay. So spindle gets that message from the CNS via the gamma motor neurons and resets his understanding of what danger means. Autogenic inhibition. In the top and bottom floors, near the musculotendinous junction of fascicle flats, muscle fiber and GTO are laying around in series, head-to-head with each other. Suddenly, GTO notices that fiber is beginning to contract. Uh-oh, GTO says to himself, that might be dangerous. Fiber is under a lot of tension or compression. So, he sends a signal to the CNS via the 1B afferent fibers to let him know. Again, the CNS considers, is the tension too much? He decides that GTO is right. So CNS sends a message down the alpha motor neuron to muscle fiber saying, stop contracting, and fiber listens. As you might imagine, with all the movement that happens in Muscletown on a regular basis, fascicle flats is a busy place all the time. GTO and spindle are on the phone with the CNS basically constantly, and fiber is always taking direction based on what they decide. The end. Now go study.